In densely populated urban areas, the overlapping coverage area between low-frequency cells is relatively large and CO channel interference is severe. This is a typical application scenario of distributed MIMO, and the maximum gain can be obtained. In common urban areas, the distance between low-frequency base stations is small, and the overlapping coverage area between cells is large. This is a typical application scenario of distributed MIMO, and the downlink throughput of cell edge UEs that experience interference can be increased. Distributed MIMO is based on time domain, frequency domain, and beam domain interference coordination technologies. It increases the throughput of cell edge UEs by using the following technologies: joint transmission interference coordination and beam domain coordination. Coherent joint transmission works in 3 steps. First, measurement for joint transmission. Second, cooperating cell selection for joint transmission. Finally, multi-cell joint transmission. Interference coordination works in 4 steps. Firstly, measurement for interference coordination. Secondly, cooperating cell selection for interference coordination. Thirdly, interference coordination scheduling. Finally, joint MCS adjustment. Beam domain coordination in distributed MIMO is supported by 8T8R cells. It works in 3 steps. Firstly, measurement for beam domain coordination. Secondly, beam and UE selection from the cooperating cell for beam domain coordination. Finally, beam domain coordination scheduling.